Assalamu alaikum. Today is our next lecture on binomial theorem. So let's start. This is question first that we will discuss here. Let's find the number of rational terms in 9 raised power 1 by 4 and 9 raised power 1 by 4 and it is 9 raised power 1 by 4 and 8 raised power 1 by 6 raised power 1000. So before proceeding the question, let's remind some basic terms that we have already discussed. The first is the binomial theorem. The binomial theorem, in fact, is the expansion. Now we have two terms, x and y raised for some positive integer n. The general term of this expansion is t of r plus 1 is equal to ncr x raised to n minus r y raised to r, where this ncr is always an integer. It means that out of n objects, I have to choose actually r objects, select. And r takes values from 0 up to n, 0 up to this n. Only integer values, not the fractional values like 1 by 2 and all that. It will take 0, 1, 2, 3, 4, 5 up to n. So let's start the question. Find the rational terms in the expansion of this one. So let's expand it by the binomial expansion. That is t. We know that t of r plus 1 is n. Here n is n in this question, n is 1000, right? And x, the first very coefficient, this very x is actually equal to 9 raised per 1 by 4, and y, this is x 8 raised per 1 by 6. Now, so this is x term raised per n minus r, y term raised per r. So this is this 1 by 4 is divided. So we have chosen 9 raised per 1 by 2. That that 2 is with 1000 minus r. Now this is 8 can be represented as this is 2 raised per 1 by 2 raised per r. So this is 1000 CR, 3 raised power, this is root of 9, 3 raised power, this 5000 minus r by 2 and r by 2. Now, since we are interested to find the rational terms means that all those terms should be actually the integer terms, integer type, not the fractional powers. So it means that this power or this power, they should be actually integers, which is only possible. How this power would be an integer? Since we have r by 2 there, so this should be an integer. This is only possible when r is an even number, which is exactly divisible by 2. So we choose it since r takes values from 0 to 1000. So 0, 2, 4, 6, only the even values, which are actually 501 in number. Actually, the half of 1 to 1000 and plus this this very quantity. So this is 501. So their total rational terms, rational number of terms, is 501, right? Now question number 2 is something different. Find the term independent of x. Means that we have to find the term in the expansion of this question which does not contain x. First, let's expand this in terms of binomial expansion. That is tr plus 1 is 10. This is n. Here n is 10. X is this quantity and y is this quantity. Now we have expanded in the binomial expansion. Now you take 2 here. So this is 5 minus r by 2, right? And then similarly 3 raised per r by 2. Now 2 and 2 cancels out, then this would be r by 2, right? And similarly 3 raised power 5 minus r by 2, right? And this is x raised power minus r. Since x is in denominator, it would be minus r, right? Now the term is independent of x, right? Now it is only independent of x when, see here, this is x and this is x. When x raised to power, this would be something like x raised power 0, that is x raised power 0 is actually 1, right? It would be like that. So comparing the powers, so this is 5 minus 3 by 2 minus r is equal to 0 into r. This is 3 by 2 is equal to 0, which implies r is equal to 10 by 3. But look here, r equal to 10 by 3 is a fraction, but we know r should be an integer, so this is not possible. So it means that no term is possible which is independent of x in this expansion, right? Now we have one more concept regarding the binomial theorem, is that in the expansion of x, say this one, x plus y raised to power n, which one is the middle term of the expansion, right? It depends upon this n, right? If n is even, then the middle term is given by this term t of n by 2 plus 1. If n is odd, then we have two middle terms. The first one is n plus 1 by 2th term and n plus 3 by 2th term. Let's illustrate this by two examples. Find the middle term of this expansion and this expansion. See here, we have deliberately chosen n equal to 14. That is, n equal to 14 means it's an even number. And here n equal to 9, this is an odd number, right? Now n equal to 14, this is even, it's odd. So here it is even, it means only one middle term. So that is given by t of 14 by 2 plus 1. That is 14 by 2 plus 1. That is t of 7 plus 1. So actually the 8th term, right? So we know how to expand it in terms of binomial in the general formula. So this is the first term here. This is x. Actually, this is y of this of the expansion. So this is 14c 14c7, 1 raised power 14 minus 7, and second term is minus times x square by 2 raised power 7. Expanding it, see here how we have expanded it. Minus is there. Now you go down by, you write 14 and go down by 7. That is 14, 13, 12, 11, 10, 9, and 8. Now, and increase from 1 to 7. So this is 1, 2, 3, 4, 5, 7. The rest terms are x raised power 14 divided by 27, x raised power 14. Calculate it, that would be the answer. The second is 3a minus a cube by 6 whole raised power 9. Here 9, n is odd, so we have two middle terms, that is n 9 plus 1 by 2. Here 9 plus 1 by 2 and 9 plus 3 by 2. That is t5 and t6. T5 can be written as t of 4 plus 1, because we know that general term is actually of this form. T of r plus 1 is ncr of x raised power n minus r y raised power r. So this is nc4, here r is then 4. Now this t6 is t5 plus 1, so r is 5. Expand both the terms, we will calculate the middle terms in this case. Here we have noticed actually we have two middle terms in this case, right? Now it means that whenever we have the power is even, we have one middle term. When the power is odd, we have two middle terms. Thank you.